Hi there. My name is Shatindra Kesudaju and my matrix number is B0921104552. Okay, today we are going to present about stand cloth hanger, which is the part of the group work. So in this slide here, as you can see, these are my fellow group mates. And to the next slide. Okay, this is the real structure of the picture, which is the cloth hanging, which assembles the triangle shape. It's called a wig stand. And this is the idealized model. And to the next slide, as you can see, this is the free body FBD, which is called free body diagram. Well, well, the stand holds for 1.5 meters, and the distance for the hang is 4 meters, and it weighs about 1,400 Newton. As you can see, it's a part of the triangle shape. And for the next slide, for my assumptions, this material, this type of material is a stainless steel. So it weighs about 1,400 Newton, and the load acting at one sided is 700 Newton. And the diameter is the 0.2 meters, and the stand is 0.04 meters. For the cross-sectional area, it's 1.9 times 10 negative 3. So the length is 400 centimeter, and with the stand, which is 200 centimeters. So it's quite big. Our project is quite big. Yeah, it's a big material. So my slide has come to the end, and thank you.
My name is Kavir Rajendran, and I'm gonna talk about the assumptions of the structure picture that we have given. The type of material is stainless steel. The weight estimation is 1400 Newton. Loading acting at one side is 700. The diameter is 0.02 meter with a stand of 0.04 meter. The length is 400 centimeter and 200 centimeter with a stand. The cross-sectional area is 1.96 meter cube. The equation of equilibrium. Since momentum at A is 0, to find FBC is 3916.67 Newton. It's round off into 3.92 kilonewton. Since the sum of force at X is 0, AX is 3133.33 Newton, and the force at AY is 950 Newton.
Good morning, madam. My name is Vignesh Nair, son of Vijayan. My matric number is B092110084. Today I'm going to explain about analysis of our structure. Analysis of structure we know has a stand of cloth hanger, and there are movement of force of a point at A to due being fixed support. And I'm going to explain about fixed support, which is they have a few reaction about rigid supports and fixed support reaction and straighten against the both rotation and translation go they can resist of type of forces which is of movement, and as we know to provide a good and stability to the structure. And madam, second one is at least one rigid support should be provided to the beam and well fixed in the wall, as we know in a free body diagram. And the beam is going to be fixed and wall is going to be good example of fixed support. That's all from me, madam. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Rahim bin Rozaimi, matrix number B0921100013. I'm from BMMH S1/1. So I'm going to talk about maximum allowable force for this structure. To calculate the maximum allowable force for this structure, we need to first calculate the stress of the structure by using load over area. The load is 1400 Newton and the area is 1.96 times 10 power of negative 3 meter square or millimeter square. And we can get the amount of 714,285.7143 Pascal. Or after move the point, we will get 0.714 megapascal. We can conclude that this design is safe in compression, but it depends on the weight it carries. Next, we need to calculate the shear stress. To calculate the shear stress, first we need by using formulas force over area. The force is the force acting on the pin over the area. So the area that we are using is 1.96 millimeter square. The force were given to the structure is 1400 Newton. So the stress we will get is 7142.8 kilopascal. We can conclude that the design is safe in pin shear. So to calculate the maximum allowable force or Fmax, we need to use the formula stress maximum times area. The stress maximum is 0.714 megapascal and the area is 1.96 millimeter square, and we can get the amount of 1.139 kilonewton. So the maximum allowable force is less than 139 kilonewton. By calculating the factor of safety using formula maximum stress divide with yield strength, we will get the maximum stress is 139 kilonewton. The yield strength is 0.714 megapascal. We will get the amount of 1.96 times 10 power of negative 3. That's all from us. Thank you.